Welcome to my web tutorial over the conservation of momentum recoil notes. So if you did not go on the website and find the conservation of momentum recoil worksheet, make sure you pick it up from the hanging file folder here at the class period, and the conservation of momentum recoil notes are on page 71. Well, so far we talked about momentum for a single object, and now we're going to talk about what happens when two objects are involved. So in short, when two objects explode or collide, there is some sort of a change and exchange of momentum from one object to the other. Now, the last thing that we talked about before we move to this particular part of the unit was talking about the magnitude and the direction. And so that required us to think about a couple of things, the magnitude and the direction. So we had to calculate the magnitude and think about what the direction would be. Now in this particular section of this unit, we are going to have to think about the two objects and how the two of them are going to change the momentum or going to make things a little bit different. So how exactly does the momentum of each of the objects going to change? Well, to understand that conceptually, we have to know the law of conservation of momentum. And that law states that the total momentum of the system remains constant no matter what momentum changes occur within the system. Now, if you will, think back to chemistry whenever you had to balance chemical equations. In order to balance the chemical equations, you had to have the same number of atoms on one side of the equation as you did on the other. If you remember, the way that we balanced those were by using a coefficient, which was a number that would go in front of the molecule or the compound, and it would change the number of atoms for every element in that compound or molecule. So what we did was we just proportionately moved numbers around and played with numbers, and so all the pieces were still there because we had a balanced reactant side to a balanced product side. And so we shift things around accordingly. That's the same thing that's happening with momentum as far as the concept goes. So if you don't understand the sentence, maybe that example helps. So you can watch this video on your own. I will post the PowerPoint, or the PowerPoint is posted if you want to watch that video. So there are three types of multi-object problems that we're going to be doing in this unit. They're called elastic collision problems. And the two types of elastic collision problems are here in the pictures that you see, the bumper cars and billiards, or layman term, pool. And then we have inelastic collision problems. An inelastic collision problem is a dead stop. As you can see, this witch has completely run into that electricity pole and is not moving backwards at all. And then we have the third type of multi-object problem, which is the recoil. And so the recoil is going to be, the example of that is going to be firearms or a shotgun. This is a shotgun. And maybe you have experience in that and you have felt this recoil. Because inside of the chamber of any type of firearm is going to be some type of an explosive, and that's going to be where our impulse begins. The very beginning of the motion of the objects. And so you can see in the middle here is the TNT, and the cannon goes backwards to the left, and the cannonball goes to the right. Okay? And so we can say that the cannonball has a negative direction. I'm sorry, the cannon has a negative direction and the cannonball has a positive direction. So explosions are going to occur when two objects start at rest. So their initial velocity is zero. And then when that TNT goes off, these two objects will suddenly separate because of the force that's going to push them apart. Okay? If you've ever gone to an ice skating rink and you've done this thing that you see with a partner, this little hand to hand. They pushed on one another, and you see that this person would go this way and the smaller person would go that way. But they're not necessarily going to move at an equal speed. Here's another video. It's actually really funny, so make sure you take the time to watch that. So explosions and recoil. In these particular problems, keep in mind that the recoil means moving away. So the two objects are going to move away from each other, and their speeds are going to be dependent upon their masses. So, like we saw the little person previously and the larger person on their ice skates, the smaller person and their mass is going to allow, with the force, there to be a higher velocity. The larger person with their mass force is going to cause, or the larger mass is going to cause a lower velocity because there's more of an object to move. However, they both have the same change in momentum. It's just shifted. Like we use the coefficients in a chemical formula to balance that chemical equation. The momentum is conserved, so the law of conservation of momentum has been met. And so now we're going to talk about the formula that we use to conserve momentum. So we have talked conceptually how this happens. Here is our mathematical version of conserving momentum. So we're going to take two momentums and equal them together. So if we have two objects that are both getting the same impulse that's going to create a force to cause them to move, one of them is going to be labeled m1 and their velocity would be v1. Make sure that your m1 is consistent with your v1, so read your problems carefully. That's the only snafu that you could possibly get into with these particular word problems. And so then the other object's mass would be m2 times its velocity v2. So the change in momentum is going to equal while these objects move in opposite directions. So here's our first problem. Our first example is I'm going to demonstrate for you the best practice in working these. So the first thing that I'm going to do is write my formula, which is what you should always do because remember that helps you get points by writing your formulas down in a test and a quiz just in case somehow you missed a number or a decimal place. So as I read my question, I'm going to underline using the different colors here of who is M1, who's V1, who's M2, and who's V2. And this is where your English skills are going to come in because you need to make sure that you're paying attention to the words. A 500 kilogram cannon. So that's going to be my M1. I have my color system going, so I've underlined it, the green. The kilogram tells me it's the mass. The cannon that is 500 kilograms fires a 5 kilogram cannonball. So, Miss Klein, how do you know which one's M1 and which one's M2? It's arbitrary. I read left to right. And so the first thing that I come to is going to be my M1 because that's the first thing in my formula. Although you could have 5 kilograms be your M1. It's up to you. Just make sure that they have the correct velocity attached to them. Now let's continue to read after we plug in our mass. 500 here, okay? 5 kilograms here. All right. If the cannonball leaves the cannon with a velocity of 90 meters per second, so 90 meters per second is a velocity. Who does it belong to? The cannon or the cannonball? Now your brain can play a trick on you and make you think that it's the cannon because the word cannon was the last word used before they gave you the velocity. But make sure that you're reading your sentence carefully because that 90 meters per second is the cannonball's velocity. So it's blue, 90 meters per second. And then it asks me to find the recoil speed of the cannon. So my V 1 is my unknown. And so now I'm going to solve for my V1. I'm going to take my 500 kilograms and I'm going to divide both sides by 500 kilograms to make sure that I end up with the correct unit, because this is what I'm solving for. I had to have meters per second squared. My kilograms cancel out. And so my V1 equals zero point 0.9 meters per second. Make sure that you're writing your units. Okay? So now we're going to go to the example 2. I'm going to let you read it, pause, answer it, and then push play, and then you can watch me do it, but I'm not going to speak. So go ahead and push pause right now so that you can practice doing this and setting it up. Thank you for joining me on my web tutorial page. Have a nice evening.